Hello, my name is Norbert Kamiński, and today I will tell you about porting fwupd to the BSD distributions. That means keeping your hardware safe with up-to-date firmware. Okay, let's start with agenda. At the beginning of the presentation, I will tell you about project genesis and BSD community concerns. Then I will go to overall information about fwupd and I will show you tool architecture. Then I will present you firmware and metadata update verification process. In the middle of my presentation, I will show you our previous ports for Cube's operating system. And then I will go to our current status of work and main problems that we face now. At the end of my presentation, I would love to hear your opinion about our project. At the beginning of my presentation, let's type "Who am I?" comment. My name is Norbert Kamiński. I'm working as embedded system engineer at FreeBSD Embedded System Consulting. I'm actively contributing to open source projects, mainly to Yocto layers like MetaPC engines or MetaTranchboot. Our last open source project were fwupd wrapper for Cube's operating system. In my scope of interest are firmware upgrade tools, virtualization, and embedded Linux. If you want to catch me, you can do it by my socials that are linked here. Why we want to port fwupd to BSD distributions? Our clients were asking us if there is easy way to upgrade firmware from BSD operating systems level. The second reason is that community were asking if there is possibility to port fwupd to BSD distributions. So we connected that facts and we've created the project fwupd port for BSD distributions that is founded by NLnet Foundation. During the discussion on BSD subreddit, there appear some concerns about fwupd project. In this presentation, I will try to clarify these doubts. Main objection were why I should trust a firmware provider. Do I need a daemon running all the time to check the updates? And I don't need this fwupd project because I can send an email to manufacturer and then update my firmware by USB stick. Let's go to some overall information about fwupd project. Security of this system is determined not only by the software in trans, but also by the firmware. The vulnerabilities of the firmware can migrate to this system, and for this particular reason, we should keep our firmware up to date. Non-Windows users face three main problems during the firmware update process. The first problem is that Windows-specific tools do not work with other systems. The second problem is that users sometimes has no idea what hardware it runs and if this hardware is supported by this firmware update. The third trouble that clarifies one of these doubts I showed in the previous slide is that it is hard sometimes to find a proper update at the internet. It's really painful, and fwupd can query your hardware, check if there is available update, and download and update this securely. So our mission is to provide the fwupd to BSD distributions to make the firmware update process easier. Let's look at fwupd architecture. It could be split into three parts. First part is internet layer, where is placed LVFS that could be extended to Linux Vendor Firmware Service. It holds in the database firmware updates and firmware metadata. Metadata contains information about possible updates that could be downloaded by this session layer. Metadata is delivered by the content delivery network, and firmware is delivered by the directly to the session layer. In this session layer, there is fwupd manager. fwupd manager holds all process of the firmware update. It asks LVFS for metadata about new updates, and if there are updates available, it asks user if he wants to upgrade his devices, and if he wants, he downloads the firmware and put it to the cache. Cache could be used to test the device to downgrade and upgrade the firmware without downloading the firmware all the time from the LVFS, and could be used also if you want to upgrade a few the same devices. So fwupd manager also contacts with the system session, where lives fwupd daemon. fwupd daemon connects with the devices and provides information about the devices to the fwupd manager, and if there is update possible, it provides new firmware to the devices. Let's talk a little more about Linux Vendor Firmware Service. The LVFS is web service that is used by manufacturer to upload the firmware. The LVFS provides also information about the updates in metadata form. The firmware is packed into cabinet files that contains metadata information about specific update. It also contains JCAT files that are used to validate the firmware process. The one who we trust in the firmware process is manufacturer, because manufacturer is signing the firmware, not LVFS service. So that clarifies that objection about trusting the firmware provider. Now I will go to firmware and metadata verification process. Since version 1.4.0, fwupd uses libjcat to verify the metadata and firmware updates. Before that version, fwupd required during the verification process PKS7 or GPG signature. libjcat allows reading and writing gzip compressed JSON catalog files that contains GPG and PKS7 signatures, and it also contains checksums of the files that are contained in the cabinet files. So during the verification process, libjcat is looking for the firmware. Then it checks if GPG and PKS7 signature matches, and also it checks checksums. The fwupd manager uses this information to validate that files that are provided from the LVFS are good to go and ready to upgrade. Now I will go to our previous part for Qube's operating system. We have implemented a wrapper for fwupd, which allows upgrading firmware in virtualized system. Vqubes is one of the most secure operating systems based on Linux kernel. It leverages Zen hypervisor to create and manage cubes, which are isolated compartments. Here you can see architecture of our wrapper. It is based on 3 cubes. First cube is update VM, which is connecting with LVFS, and it's downloading the firmware for the device. Second is Doom0, the administration VM, which allows to communicate with the device. And the last cube is CCUSB, which allows to communicate with devices connected to the USB. Whole operation of the update is handled by Qube's fwupd manager, which calls the update VM to download the firmware. Then it is cached like in the fwupd architecture. It's also validated on every step of the firmware process, updating firmware process. Then it is transferred from the one virtual machine to the other. The other once again validates this same update file, and then it distributed to the fwupd daemon in admin VM, or once again transfer it to the CCUSB VM. Then daemons are installing the updates of the firmware. We would like to provide the fwupd functionalities for 4 distributions: FreeBSD, DragonFlyBSD, NetBSD, and OpenBSD. First of all, we would like to implement firmware updates for USB devices. After that, we'll implement the UEFI capsule updates for motherboards and UEFI-based devices. Currently, we are trying to compile fwupd under the FreeBSD distribution. Most of the fwupd dependencies is already available in the FreeBSD package manager. But we are facing some problems. libgusb is hard requirement of the fwupd. Port of this library was started by Ting Wei Lan, and this library is based on libusb 1.0. FreeBSD distribution provides its own implementation of this library, but this implementation lacks in function that libgusb is using, and this function are specified in the FreeBSD Bugzilla in this thread. During the messing configuration, we are looking for libraries with find library method of the compiler object. This method doesn't work correctly, so we have to change it to hard dependency to make the configuration of the project work correctly. So FreeBSD also uses devd instead of udev, so we have to turn off all plugins that are using udev, or in the later stage we can just replace udev with devd. Also, there is no systemd in BSD distributions, so we have to turn off this option. Another problem is that FreeBSD kernel does not support ESRT. ESRT is EFI System Resource Table which is based for UEFI capsule update. The ESRT provides a read-only catalog of system components which the system accepts to be upgraded via UEFI capsule update feature. The module allows userland to evaluate what firmware updates can be applied to the hardware and devices. Now, when you are trying to compile the fwupd, we are failing due to Linux header dependencies. So we have to fix that as well. If you want to contact us, here are the links. We are open to discuss and cooperate. And now it's time for questions. We would love to hear your opinion about the port of fwupd for BSD distributions. Thank you. Thank you for the attention, and I'm waiting for questions.
So, okay.
Someone is typing.
Can you hear me?
Yeah, I can hear you, and you can hear me. Thank you.
Thank you. Yes, thank you for your great presentation. So now it's time for questions. So please, if you have questions, you can write it on the BSD div room chat.
If you have any doubts about this project, you can also type them in BSD chat, and I will try to answer them. Maybe I will tell you some more about the progress of this project. Now we can compile the fwupd project in FreeBSD distribution. We turn off all the plugins that are connected with Linux, and we created some if-defines in the fwupd project. Currently, we are able to get some information in development tool that is called fwupd tool. And we are able to refresh metadata. That means there are some information about the available updates, like I said in my presentation. So now we are trying to fix the problems that are connected with the configuration, localization of configuration files in BSD distribution, because that differs from the Linux one. I will really appreciate your opinion about this project, because I heard some comments in Reddit, and I will really appreciate if you would say something about that.
Okay. So, if you don't have questions regarding this project, maybe.
Oh, there is one.
Okay, there's a question. Okay, go ahead.
Okay, is there? Wait a second. Is there any privilege separation work in fwupd? Probably it's too early for something like that, but it would be possible to run this under capsicum or something similar. And also thanks for picking that. Yeah, there is privilege separation in fwupd. You need the sudo privileges to update the firmware of the device, and you have to accept this firmware update. So it won't be without your knowledge. Device won't be updated without your knowledge. I can, okay, but would it be possible to run under capsicum or something similar? I'm not sure what you mean under the term of capsicum, so maybe you can clarify, or I will just Google that.
Just to clarify, yes, capsicum is the security framework under FreeBSD. So
Okay.
you can provide, or you can drop privileges from an application. So
Okay.
as an example, when an application needs to access a file, once you access the file and have the file descriptor, you can drop the privileges to access the file system. So you guarantee nobody can use your applications to perform undesired actions.
Okay, I understand. We have to look at that for sure, and it's really important to make this vulnerable operations like updating the firmware in secure way. So it will be really helpful to use this framework. I will make some notes on my left side. Thank you for your great talk. Thank you. I appreciate that you want to watch it. It's very important to have firmware updated on every system. Yeah, I agree. I think this project is very important. I will look forward. I have camera here and I cannot read all the question. Wait a second. Okay. I think this is a very important project, and I will look forward to its production-ready version. Yeah, I will appreciate that, and I think we will send some status blog posts on our site, FreeBSD site, where we'll inform you how is project going and where we are in current time.
I think there is probably one question. Oh no, it's just thanks.
Okay, thank you so much. Thank you so much for your question.
Thank you for your presentation. It's a very good one.
Yeah,
okay.
It's my first presentation on FOSDEM. Last year I was just a viewer in Brussels, in Belgium, and now I'm the presenter in virtual event. That's really cool.
Okay, so don't hesitate to come back next year. I hope next year we'll all be in a real room with people and so on.
Yeah, we should talk about this, about putting the fwupd in Hello System. Yeah, I agree.
Excellent. So thank you very much.
Thank you.
And if there's no more question, I think we can close here the Q&A session. And,
okay,
leave the room for the next one.
Encourage you to contact me if you have any more questions. And thank you once again for your time.
Thank you very much.
Thank you. Bye.
Bye.